Hello students, in this section we are going to deal with isochoric process and isobaric process. What is meant by isochoric process? Isochoric process means the volume is constant while all the other variables will change. So, the process, it is a thermodynamic process in which the volume remains constant. Such kind of process is called isochoric process. So, as the volume is kept constant, delta V is equal to 0, change in volume is equal to 0, and P into delta V is called work. Therefore, what can I say? Work is 0. Understood? Since volume is constant, delta V, change in volume is 0. So, P into delta V is 0, P into delta V is called work, work is 0. So, since work is 0, heat absorbed by the gas is completely used to change its internal energy, that means temperature. If I supply the heat, there is no change in the volume. So, the heat that I am supplying is only used for what? Increase the internal energy or increase the temperature. Therefore, I am going to apply this concept in the first law. Delta Q is equal to delta U plus delta W. Delta W is equal to 0. So, delta Q equal to delta U. That is what it is written here. Heat supplied is completely used for the change in the internal energy. Okay. Heat supplied is completely used to change the internal energy and the temperature of the system. So, here I am giving an example. If we heat a gas filled in a closed cylinder pistoned with a piston. So, here the piston is fixed and I am just heating the gas. When we supply heat to the cylinder, the piston won't move as there is no volume change. So, the piston is immovable, I have fixed it. So, the piston cannot move up, so there is no change in the volume. Therefore, what will happen? There is no work. Gas cannot expand, there is no work. So, whatever heat is added will be used to increase the internal energy. Now, the next thing is isobaric process. Iso means same, bar related to pressure. So, isobaric process means it is a thermodynamic process in which the pressure of the system remains constant. So, pressure of the system remains constant. So, only the pressure constant, volume will not be constant, volume will change. So, work is done. Therefore, I will be writing work done as P into V2 minus V1, and that is equal to mu R into T2 minus T1, because PV is equal to mu RT. So, P into V2 minus V1 is equal to mu R into T2 minus T1. Now, from the first law of thermodynamics, delta Q is equal to delta U plus delta W, right? So, instead of delta W, now what I can write from here? W, as I told you, it is P into V2 minus V1, and PV is equal to nRT mu RT. So, mu R T2 minus T1. So, instead of delta W, now I can write mu R T2 minus T1. So, we can see from the equation that the heat absorbed goes partly to increase the internal energy and partly to do the work. A part of the heat is used to increase the internal energy and a part of the heat is used to do the work. That is about isochoric process, isobaric process. Now, example, consider a cylinder filled with a gas fitted with a piston. When we heat the cylinder, the gas expands but the pressure remains the same because of the piston. Now the piston is free to move. In the previous case, the piston was fixed. Now the piston is free to move. So as you heat, the piston goes up and the gas will expand. Then boiling water in an open pot, which is at atmospheric pressure. When the water boils, it changes the steam and the steam expands, and since it is not contained, it stays at atmospheric pressure. So the pressure remains constant, but the energy will change. If I am closing the lid, the pressure will increase. If I am keeping the lid open, the pressure will remain constant. Now the next thing, cyclic process. What is meant by cyclic process? It is a process in which the system will come back to the initial stage. Cyclic. The system will come back to the initial stage. So imagine like this, ice is changing to water, water to vapor, vapor back to water, then back to ice. Cyclic. So in the cyclic process, the change in internal energy will be 0. Delta U will be equal to 0, which means the total heat absorbed equal to work done by the system. When you apply first law of thermodynamics, delta Q is equal to delta U plus delta W. Delta U is equal to 0. So delta Q equal to delta W. That means work done is equal to heat supplied. So the system started from point 1, you just see the figure. The system started from point 1, it went through series of process, whether it is isothermal or adiabatic or isochoric or isobaric, any process, it is going through different process. But finally it comes back, it reaches to position 2, and from position 2 it is coming back to the initial position 1. So in this stage the internal energy is increasing, and in this stage internal energy is decreasing, and it comes back to the original state. So total internal energy will be 0. So here you can see delta Q is equal to delta U is equal to delta Q plus delta W. So delta U is 0, so W is equal to Q. So work done by the system in a cyclic process is equal to the heat absorbed by the system. Example, heat engine and heat pump. Heat engine we are familiar. Heat is given to the engine and engine converts heat into mechanical work. That is the engine that we are using in cars on all the vehicles. Last year we had to study the working of heat engine, but this year they have deleted that from the topic, so we don't have to go to the heat engines in detail. It just think like this: heat engine is a device which converts heat energy to work by a cyclic process. Because piston will go up, you have seen in the ads also, in the engine oil ads for the cars, they are showing the piston is going up and coming down, something like this. There are 4 cylinders and one will go up down like that. So that is actually the cyclic motion, cyclic process. That is the heat engine. Okay. Now when I draw the pressure volume graph for isothermal process, PV graph, I already told you isothermal process is a very slow process. So if I draw the pressure volume graph, the graph will be a curved line. This is for isothermal. Now Now I am drawing the same graph for adiabatic. When you draw the same graph for adiabatic, the adiabatic process is a fast process. So you can see one is a slow process, other is a fast process. So when you draw the graph for adiabatic and isothermal, it should be less slope and it should have more slope. Now the next graph. Isochoric. Isochoric process, volume remains constant, right? So whatever changes, volume will not change. So the graph, PV graph will be like this. Volume is constant. Now the next thing is isobaric process. So in isobaric process, which remains constant? Bar for pressure. So pressure remains constant. So even though volume increases, the pressure remains same. So this is the graph for isobaric process. So you can take down these graphs also. That's all in this section. Thank you.